Yeah, Shavis, can we start? Shavis, you have a doubt or no?
Sir, can you explain seventh question in exercise 5.7?
Says 5.7, question number 7. Yeah. E to the power 6x into cos 3x. Right? Cool. So let's consider first of all y is this, right? Now we have to differentiate it. And so what's the problem first of all, Pari? I mean, this is just a product rule, right? Did you understand?
Yes, sir, but I couldn't resolve it. I had some doubt.
So let's start finding out the derivative by differentiating with respect to x both sides. So it will be dy by dx, correct? And then product rule will be applied here. One function is exponential, e to the power 3x, and second is trigonometric cos 3x. So we will assume one function constant at a time. Right? So first let's differentiate e to the power 3x. So e to the power 3x will be e to the power 3x first, into 3x will be 3, right? I mean, this is not just e to the power x. This is e to the power 3x, right? So we have to apply chain rule. So while applying chain rule, e to the power 3x will be e to the power 3x into, then we
There
will
is
go
e to the power 6x.
to the power 6x. Okay. In that case, this will change to e to the power 6x into 6, and then cos 3x will be as it is, right? Plus e to the power 6x will be as it is, and then cos 3x will be minus sin 3x, and then 3x, that would be 3. So you can basically take 3 into e to the power 6x common. So you'll be left with 2 cos 3x, right, minus sin 3x. That should be the final answer. Sorry, did you get it? And also check whether this is the correct answer or not.
Okay, so I'll check.
Guys, have you solved the questions from assignment? I mean, there were some good, really good questions from this assignment which I assigned you in the last class. Have you gone through them? Okay, so you have no doubts from this. In that case, you guys have to solve some of the questions. First of all, my question to you is, and everybody has to answer this. Did you get differentiation, how to differentiate a function? First of all, basic functions, like, do you remember the formula and differentiation of basic functions? Till chain rule. Okay. And other ones, Humamuddin?
Yes.
And Tariq, Shahid?
Yes, sir.
What about Shahid and Chavez? Okay.
Yes.
Okay. Because see, a lot of questions will come from this chapter in the final exam, and if you're not able to solve basic differentiation, then you won't be able to solve basic, I mean, integration as well. So the whole calculus depends how good you are in the current chapter. That is why I mean, I'm stressing. Okay, I don't think we need a actually new column for this. So there's only one doubt on this. Please start solving the questions, because if you solve, then you will definitely get doubts. Uh, a lot of questions are way more tougher what you are thinking. So start solving these questions. Okay, so first of all, we'll start with application of derivatives today. I'll tell you I'll introduce the topic to you guys. Okay, but first, let's check the syllabus. What is our syllabus for? Okay, so application of derivatives involve rate of change of quantities, increasing, decreasing functions, maximum and minimum. First derivative test motivated geometrically, and second derivative test given as a provable rule. Simple problems that illustrate basic principles. Okay, cool. We have what used to happen in this was there were 5 topics, but I think they have reduced the topics now. So let's start with the first topic, rate of change of quantities. So, just give me a moment. Yeah. So let's start with rate of change of quantities, and also the introduction of the chapter. So first of all, what are we having in the chapter is application of derivatives. We will understand how to apply, we have understood how to differentiate a function, and how, different kind of functions, as well as application of logarithm and 10 parametric forms, right? So we have been introduced to a lot of different kind of functions, and also the differentiation of them. But what are we actually achieving by differentiating the function? I mean, what is the application that where are the areas that we can apply differentiation, or why do we even invent such a thing? I mean, to some, this may be boring. So why are we inventing this? So this chapter basically deals with application part of differentiation. So we can apply derivatives at a lot of places. Uh, I mean, if you are into engineering, then a lot of fields involve application of derivatives, in which there are a lot of equations which can be only solved if you know the differentiation part. So basically what we do is, I'll give you an example regarding a business. So what are functions? Functions are basically, when we do business, then revenue may be a function. How much revenue you are generating may be a function, and function of the variables. Your variables can be, for example, marketing, or all of your this marketing budget is your one factor that impacts your revenue. right? So this is a variable. There must be some relationship between between how much you spend on marketing and how much you are generating the revenue, right? So there can be functions which, there will be functions which can be made using the different variables, and the functions are generally cost or cost functions, revenue functions, things like that. And then you have to differentiate those kind of functions. Why? Because you want to optimize, or you want to optimize the, revenue, for example, or maybe cost for something. So, for example, if you want to understand how much cost on marketing impact your revenue, then you have to differentiate the function and do, perform certain kind of mathematical operations, and then you will get to know the value of money that you should spend on marketing or something different, some different variable, right? So that is what involves application of derivatives. So we will first start with rate of change of quantity. So I told you in the beginning what was the meaning of dy by dx. If you want to visualize what is dy by dx representing, so dy by dx was basically change in y with respect to change in x, right? So what are you guys getting here is, let's say you have a relationship between some kind of function. Let's consider this function only. Let's consider two functions. Okay, this will also work as a nice example for what I want to tell you. So dy by dx, let's first start with this. Dy by dx is change in y, change in y with respect to change in x. You want to understand how change in one variable is impacting another variable when they are both related by some kind of function or expression. Okay. So let's take two expression now. First take this y is equals to 2x, or let's say y is equals to x only. And second one is y is equals to x square, right? So let's calculate dy by dx. Also one area where we didn't touch upon in differentiation was, I would like to tell you, let's say dy by dx is 2x, right? Now I can also find out the value of dy by dx at different points, right? For example, if I want to find out the value of change, dy by dx at certain value of x, then I can find that. I just have to put that value. So if I want to find out the value of dy by dx at x is equals to 1, I would be writing it like dy by dx at x is equals to 1. This will be the way, and we will put the value for x. You will get the answer, right? So you can take some different function, maybe, for example, go to the fifth chapter. Right, see, this was dy by dx. Right? If I want to find out the value of dy by dx at certain point, then I can do that, right? For example, if in this case, you put dy by dx at x is equals to 0, or at t is equals to 0, let's say. Okay, we can't put t0 here. So let's say dy by dx at x is equals to 1. So if I put, or no, not at x is equals to 1. For x is equals to 1, we have to solve the equation. It's a t is equals to 1. So in that case, t is equals to 1. I will put the value of t because the variable is right now t. But I can certainly put the values of variable, or I can find out the value of dy by dx at different values of variables. Right? I just need to put that variable into the equation. And in this case, this will be 1 plus 1. If you put t is equals to 1, so t plus 1 upon t will become 2. Right? So this will be a square, and this will be a. So this will become a log a divided by, this will become 2 to the power a minus 1. Right? That will be the answer if you want to find out dy by dx at t is equals to 1. So similarly, we can also apply the, say in the similar terms, we have applied dy by dx here to the values too. We can find out the values at different points. Yeah. So let's take these 2 points. This case, take these 2 functions, y is equals to x and y is equals to x square. And in this case, dy by dx is to differentiate both sides with respect to x, then dy by dx is equals to 1, right? And in this case, dy by dx is equals to 2x. Now, this is a linear function, right? This is a linear. And this is a quadratic function. We know these functions. Now, in this case, if you find out the value of dy by dx at x is equals to 1, the value will be 1 only because there is no x involved, right? Dy by dx is a constant term. The value is 1. So whatever x you put, your expression for, the rate of change of y with respect to the rate of change of x is constant. Whatever you change x with, right, the similar change will happen in y. Now, what does this mean is, let's say you are, take x is equals to 1. In that case, y is also 1. Now take x is equals to 2. Now y is also 2. Now observe the change that happened in x and that happened in y. If x increased by 1, then y also increased by 1. The change in x is directly proportional or directly equal, basically equal to the change in y. That is what it is saying. dy by dx is equals to 1, right? So if you change x 3, y is also 3. Now also you can observe this. If you take x is equals to 1 is the first point and x is equals to 3 as the second point, in that case, the change in x is 2 and change in y is also 2. See, the same change is happening throughout y, whatever change is happening throughout x, right? So basically, we are relating change in x with respect to change in y. And in this case, when the function is linear, the change is constant, right? Whatever changes, for example, let's say y is equals to, in place of y is equals to x, we have y is equals to 2x. Now dy by dx is 2, right? So at every place, whatever your x is, dy by dx will remain 2. Right? Now if you change, now if you observe, whatever change you will make in x now, the double will become in the change in y will become double of that. So for example, if you take x1 in this case, and y will be 2 in that case. If you take x is equals to 2, then y will be 4. See, the change in x is 1, but the change in y is twice. Right? So this is an indicator. Dy by dx can act as an indicator for the change in one quantity with respect to the change in another quantity. Right? Now let's also observe y is equals to x square. So this is for your, this is a fun exercise only. This is not relating to how will we solve the questions, but this will give you an understanding about how the things are working. How the things are going. Right? So dy by dx in this case is 2x. Now let's put some different values of x in this function. So this is saying that dy by dx depends on the x, right? Y is equals to x square and dy by dx is equals to 2x means that the value of dy by dx will change as the x changes, right? In fact, if you increase x, then the change in y will be higher. No? It will keep on increasing. For example, if you put x is equals to 5, then dy by dx is 10. At x5, dy by dx, y will be changing 5 times to x. If you will make a change of 1 unit, then y will change with 5 units. Oh, sorry. Yeah. Y will change with 10 units. Right. So this also means that dy by dx can depend on x, right? So if we have a relationship between y and x, then we can find out the change in y with respect to the change in x. That is what we are going to apply in rate of change of quantities. So just give me a minute. Let's start with this. Yeah. Let's put x is equals to 1 in this case. So if you put x is equals to 1, then y will also be 1. If you put x is equals to 2, then y will be 4. If you put x is equals to 3, then y will be 9. Right? So by changing x1, by changing x, if change in x is 1, then change in y was 3 in this case, right? If change in x is again 1, let's see, the change in y is 5. Why? Because it depends on the x. If your x is increasing, the change is also increasing. Right? Because dy by dx was not, constant. It depends on the x. So as your x increases, the change in y increases. Keeps on increasing if you, put the bigger values of x, right? And that is also, this is also a term like, this is a term to represent growth sometimes, like quadratic growth or exponential growth. So it means that their curves actually, uh, the curves of these functions are more vertical. So for example, if we see the curve of y is equals to x squared, then this is like that. So I mean, you can observe that the function is keeps on increasing as the x increases. Yeah. So let's start with the first thing was, let's start with this later. So first thing was dy by dx was, dy by dx means change in y with respect to change in x. And then if we consider this dy by dx at x is equals to a means change in y with respect to change in x at some point x is equals to a. You can put the value of x if you're given, and that will help you out in finding out the value of dy by dx at that particular point. Yeah. So let's start with a example only. This is given in your NCERT. Example 1. The example is find the rate of change of the area. Yeah, mostly there will be uh, word problems in this chapter, and things will be based on your basic relationship. The area and most of the formula from area chapter uh, will come handy. If you don't remember the area simple figures, then please revise them. This will happen in the today's class only. So let's start with the question. So this is given that find the rate of change of the area of a circle per second with respect to its radius. Right? R, when R is 5 centimeter. So we have to find out the rate of change of area of a circle. So first understand what are the important points. Area of a circle, rate of change, area of a circle per second, okay, and radius r. Right? So we know what is the formula of area of a circle. So to find out the rate of change of area of a circle, we have to basically understand what is happening here. Area of a circle can be written as pi r square, right? If we know radius, then we can find out the area. This is a relationship that we know. Here we are asked rate of change of area of a circle per second with respect to its radius when r is equals to 5 centimeter. Then per second, no, this is the question is actually wrong. It cannot be per second. Uh, in that case, we will have to find out. I mean, in that case, we will have to give. I mean, see, the important point is to understand how to differentiate the given function. And I mean, how to differentiate the given. Not, I mean, we know the process of how to differentiate, but in with respect to what you are going to differentiate the given equation. For example, in this case, you have to find the rate of change. So whenever rate of change is involved, generally rate term is used to find out the derivative of something with respect to time. Rate is generally used for time. But whenever you solve any question in physics, you may have noticed this or not, but in physics we use this term a lot, rate, and it is generally used for time. Generally used for time money. It basically represents generally used for derivative with respect to time or change with time. Derivative with respect to time, right? So whenever rate of change is being asked and nothing is defined, I mean there is nothing given. In that case, you must differentiate the given equation in terms of time. But in this case, if I differentiate the given equation in terms of in that case, you must differentiate this with time. But if I mean, chalo, let's see what is the problem here. Why did I say that this question is wrong? So rate of change is generally meant for time, right? So when the question asked me about rate of change of area of a circle, so it means that I have to differentiate the given equation with respect to time, and also per second is also given here, right? So per second माने भी यही है कि I mean the denominator should be in seconds and denominator should be in seconds. When will it happen? When, I mean, you can check it with the help of dimensions also. That second is the unit of time, right? So we will have to differentiate this with respect to time. Now let's differentiate this with respect to time. So understand the variables first. Area is a variable, right? We don't know about area. Pi is a constant, r is also a variable, right? So if I differentiate this with respect to then dA by dt is equals to pi is a constant, r square will be 2r into dr by dt. Right? And r in itself is also a variable. We don't know the rate of change of r with respect to t. Constant is a constant, but if you want to differentiate any variable with respect to another variable, then that value must be known. Now, if you want to find out the rate of change of area, that is dA by dt, in that must know about dr by dt, but they have not given us the by dt. I mean, there will be questions where this because same question can be made correct. Yeah. So if I give it dA, the value of dr by dt, that is the rate of change of radius with respect to time, and let's say that is 7 centimeter per second, then I can find out the value of dA by dt, the rate of change of area. And in that case, the value will be, we know R, what is R? We know dr by dt. So dA by dt at R is equals to 5 will be 5 into 2, 10. This will be 10 pi into 7 dr by dt. The value will be 75, and this will be centimeter square per second. You can also notice that there is a R here. So 1 centimeter is from here, and dr by dt is also in centimeter per second, right? So centimeter square per second. The unit is also right. So the rate of change of area, if given the radius and the rate of change of radius per unit time, can be found out like this. So these are basic questions, very basic exercise. This will be the easiest exercise among all the topics. We will understand the three. I mean, there were 5 topics, but now they are reduced to 3. So we will understand 3 different applications of derivatives. This is the first one, and this is also the easiest. You just have to. It will not consist more than 2 or 3 marks. So there will be a question like this. It will consist 2 marks, or maybe 1 marker question. Then it will be, one. This is a 1 marker question, and there will be a 2 marker question. So which will be calculated, in which they may give us 2 different expression, and then we will have to differentiate one and find out the value from one, and then put it in second expression. So the questions are easier. You just have to remember these basic formulae of area and surface area, then volume. So these general, what we used to call it, whatever the geometrical things and dimensions. Yeah, so let's start with a good question now. Okay, so let's start with the second example. The volume of a cube is increasing. Okay, yeah. एक चीज और I want to show you one more thing. Just give me a minute. Let's focus on this thing first, which I'm about to start. So let's say we have a function y is equals to cos x. Okay. You know the differentiation of cos x, right? dy by dx is minus sin x. This is negative, right? Now I want you to understand why it is negative. Okay. Let's put the values of x in this question. So let's put x is equals to 0 degree. Okay. If x is equals to 0 degree, then y is 1, cos 0. Now let's put x is equals to 90 degree. If we put x is equals to 90 degree, then the value is 0, right? See, we have increased x, right? We have increased x, but the value of y decreases. As we increased x from 0 to 90 degree, the value of y goes from 1 to 0, right? So if you find out change in x and change in y in this case, so change in x, first change in y, delta y, we can write it like, the change can be represented by delta. So delta y in this case is, so now how would you find out the change? Take one value and then subtract the other. Now let's take 1 first and 0 second. So 1 minus 0 is 1. But the same order you have to take for x. So 0 minus 90 is minus 90. Right? So you can see that the delta y upon delta x is negative in this case. Why is this happening? Because when x increases, y decreases. So when the value of dy by dx is negative, it only means that as x increases, then your y is also increasing. Basically, if one variable is increasing, then another is also increasing. Sorry, this is for positive. If delta y by delta x is positive, and if delta y by delta x is negative, it means that if x is increasing, y is decreasing, or if x is decreasing, then y is increasing, vice versa. Right? So dy by dx positive money, simple, है ना? dy by dx. If dy by dx is positive, it means that sorry, sorry. So what does this mean? How did we write this? If dy by dx is positive, it means y increases as x increases. And if dy by dx is negative, it means that y decreases as x increases. So now in this case, the volume of a cube is increasing at a rate of 9 cubic centimeters per second. See, they have again used the term rate, and now let's also focus on the units of the, unit, what they have given us. Increasing at a rate of 9 cubic centimeter. 9 cubic centimeter, 9 centimeter cube per second. Right? See, so this you will have also have to notice the units every time whenever rate is discussed or whenever rate is used. In this case, the unit is second, which basically amplifies the belief that rate is used for time. How fast is the surface area increasing when the length of an edge? So first, understand the question. What is given to us? What are the important things? What do we need to find out? So we need to find out this. How fast? Okay, we need to identify this. How fast the surface area is increasing. Okay. And we are given with volume of a cube, which is also increasing at the rate of 9 centimeter cube per second. Right? So can you identify what is given to us? How to write what is given to us? This is 9 centimeter cube. Sorry, Travis.
d of a cube by d is equal to 9.
No, well, first of all, we can say derivative of the volume divided by dt. No?
Yes, sir.
Yeah. So volume of a cube is increasing. We are talking about a cube and specifically about volume of a cube. And this is increasing at the rate 9 centimeter cube per second. It only means that, let's say, if the volume of the cube is V, The volume of the cube is V, and the side of the cube is A. Yeah, edge of the cube. Right. Now, if we know that V is the volume and A is the edge, then we know how to write volume of cube in terms of A, right? How to connect V and A. And what is given to us will be dV by dt, which is 9 centimeter cube per second, right? See, now the value of dy by dt is given to us. So we have to use this value to find out some value maybe. And what else is given? We are given that A is equals to 10 centimeter. We have to find out ds by dt. So let's write this thing also, that S is the surface area. Right? We are also talking about surface area of cube. So we want to find out ds by dt, right? Rate of change of how fast the surface area is increasing when your length of edge is 10 centimeter. We want to find out ds by dt at A is equals to 10 centimeter. This is the goal. Right? So first of all, write the formula of volume, which is A cube, and also for surface area, which is, can someone tell me the formula of the surface area of cube? Surface area माने total surface area. Okay, what is the surface area of one side, one face of the cube? How many faces does a cube have? Hey. Very tough question, huh? 6 or ये भी text पे. So yeah. So and what is the area of one face of a cube? This is a square, right? A face of a cube is a square.
Yes.
A square. No, A into A. So 6A square. There are 6 faces. So the surface area of a cube is 6A square and volume of a cube is A cube. We know dV by dt and we want to find out ds by dt. Definitely they both have a relationship with A, so definitely A will be involved. So when so let's try to find out what is being asked, right? So if I differentiate the whole equation with respect to t, this will be ds by dt, right? And this will be 6 as it is. A square will be 2a into the differentiation of a dA by dt. A is also constant. I mean, S and V depends on A, right? So in general, A will be a constant value for a particular case, but in general, A is a variable, right? We don't know about A. So we also have to differentiate A with respect to time because we don't know what is the rate of change of edge of the cube with respect to rate of change of the edge of cube. So ds by dt will be 12a into dA by dt. Now it is given to me that the value of A is 10. We have to find out ds by dt at A is equals to 10, right? But we don't know the value of dA by dt. So for that, this is given. Volume of a cube is increasing at the rate of 9 centimeter cube per second. So this information will be used to find out dA by dt. So, and we want to find out dA by dt also at A is equals to 10 centimeter only. I mean, if I'm finding out the surface area, I mean, increase in surface area at and length of edge is given, then the same length of edge will be used to find out dA by dt as well, right? Okay, so this D, I mean, use this information. V is equals to A cube and dV by dt is equals to 9 centimeter cube per second to find out dA by dt. For that, we have to differentiate this equation, which will be dV by dt is equals to 3a square into dA by dt. Right? We have dV by dt, which is 9 centimeter cube per second. We have a, which is 10. So this will be 10 square will be 100, 100 into 3 will be 300, right? And we have dA by dt. So this will be 9 by 300, right? Or one more thing, what we can do is, we can also think it like that. We know the value of dV by dt, right? Which is 9. Let's say we don't know the value of a square. Although the value will be used 10 only, but let's say we don't know the value, what should we put in place of a? So this will become, if you take 3a square to the left hand side, then this will become dA, the value of dA by dt will be 3 by a square, right? So there is a 9. This will become 3 by a square. Now, if you use this first equation, using 1, I can say that ds by dt will be 12a into 3 by a square, right? Which would be 36 by a. And now you can see that you again have to use the value of a as 10. But this is also a way, this will, save you some calculation. So you don't need to calculate everywhere, just calculating the last. Put the value of a now, ds by dt at a is equals to 10 will be 36 by 10, which is 3.6. Now this will be a 2-mark question. दो ही तरीके के क्वेश्चन है यहाँ से, एक 1 mark का 2 mark का, and pretty easy questions will be there. So I don't think you should face difficulty in handling them. But let's start solving some. Okay, so do everyone have NCERT? If you don't have NCERT, please raise your hand. Oh, okay. So in that case, we'll have to write the question. Everybody else can refer to question number 5 from exercise 6.1. I guess page number 197.
Which question?
Question number 5. Stone is dropped. So I'll only write useful information. We don't need the whole information. So this is, a stone is dropped into a quiet lake and waves move in circles at the speed of 5 centimeter per second, right? So, and at the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? So a stone is dropped into lake, stone, waves. Right? Now we know how are waves. Waves are circular, right? And waves are moving in the circles at the speed of 5 centimeter per second. Right? Now, can you identify what is given to us in this case? This is 5 centimeter per second. take the help of units as well. I mean,
So
unit
is
is a
it dr by dt? Radius
dr by dt, which r is radius. Oh, no, no, no.
So radius is increasing at the rate of 5 centimeter per second.
Yeah. No, sorry. It is not dr by dt. My bad. It is okay. Think about it. But first of all, take the help of I mean this the unit also. But the guess was incorrect. This is not dr by dt. And at the instant when the radius of the circular wave is 8 centimeter, okay, so radius is 8 centimeter, and how fast is the enclosed area increasing? No, no, you are correct. This is dr by dt only. This is actually dr by dt. You're correct. I mean, this would have represented one more thing, uh, which is what, uh, which is change in circumference. Right? But right now, this is not representing change in circumference because the circular waves are moving and they will be moving like this one. So there's a circular wave, and then how does they move? This they moves outside. Right? So the change, I mean, the speed is given with respect to radius only. This is dr by dt. Lake stone waves are moving with 5 centimeter per second. So this is dr by dt. Also notice that circumference of a circle is 2 pi r. So if you want to find out change with respect to circumference, so dc by dt, then that would be what? 2 pi is a constant, and this will be dr by dt, right? So the change, I mean, the unit of the circumference, change of circumference or rate of circumference will be same as rate of radius. Don't get confused. I mean, that if centimeter per second is given, then it has to be radius. It can be change in circumference, or I mean, rate of change of circumference also. But in this case, this is definitely dr by dt. Change or rate of change of radius is given. So, and radius is also given at the instant when we have to find out the increase in area or the change in area. So we basically have dr by dt and r. We have to apply the formula of area of a circle, and then we have to find out dA by dt, right? So area of a circle is pi r square. Then for rate of change of area, differentiate with respect to time, so, which is generally t. So this will be dA by dt is equals to pi is a constant. R square will be 2r into dr by dt. We know the value of r. We know the value of dr by dt. Hence, dA by dt at r is equals to 8 would be 8 into 216 into this is 5. So pi into 2 into 8 into 5 will be 80 pi. Please feel free to reach out if you have a problem. Yes, correct. Awesome. Unit will be centimeter square per second. Always focus on the units also. My bad. I forgot. Always write the final answer with unit. Okay, and whenever length x of a rectangle in the fourth question, length x of a rectangle is decreasing. So whenever the word decreasing will be used, it means that if y is, I mean, if x is increasing, then y is decreasing.
Negative.
Yeah. So you basically have to consider a negative sign, whatever is given to us. So for example, in the, in second question, you can see that volume of a cube is increasing given to us. Increasing money positive. That is why we took the value of dv by dt as plus 9 centimeter cube per second. If volume of a cube was decreasing at the rate of 9 centimeter cube per second, then dv by dt would have been written as minus 9 centimeter cube per second. Wait. So length x of a rectangle is decreasing. It means that if you find out dx with respect to something, with respect to whatever it is decreasing, then you will have to use the negative sign. Okay. The length x of a rectangle is decreasing at the rate of 5 centimeter per minute. Per minute. Okay. And then width y is increasing. And increasing with 4 centimeter per minute. Now, when x is 8 and y is 6, find the rates of change of. You basically have to find two things. Rate of change of perimeter and area of the rectangle. Can we solve this one? You have 2 minutes. Please try to solve this question. Length x is given. It is decreasing. So basically, you are given dx by dt, which would be minus 5 centimeter per minute. And then dy by dt is also given, which is 4 centimeter per minute. You need to find out rate of change of perimeter of the rectangle. Basically, if you take perimeter as b, then you need to find out dp by dt. And if you take area of the rectangle as a, then you have to find out dA by dt. Right? And you have been given everything. So let's solve this one. Guys, do we have an answer?
Perimeter edit.
Sorry.
Perimeter what?
First, okay. Tell me the answer.
Sir, what?
It's okay. You can tell me the answer.
Yes, 1 centimeter per minute.
Anji, can someone tell me the formula of perimeter of a rectangle? The toughest question of the class today. Yes, minus 2 centimeter per second. Okay, let's find out. So first of all, tell me the formula of
Sir,
perimeter of a rectangle here.
it will wrong answer.
Yeah, twice length plus breadth, right? So this should be twice of x plus y. And simultaneously, let's also write the formula of area of a rectangle, right? So in this case, there are two variables on which perimeter and area depends, which are x and y. So if I differentiate p with respect to t, I want to find out dp by dt, right? So dp by dt would be twice now dx by dt plus dy by dt. We'll have to differentiate x with respect to t and y also with respect to t. We know the value of dx by dt, dy by dt, as well as x and y. So this will be pp by dt is equals to twice of this was minus 5, I guess, and minus 6, minus 5, right? This was plus 4. This should be centimeter per second, right? And in that case, minus 5 plus 4 is minus 1, minus 2 centimeter per second. Sorry, minute. Now here we have to apply product rule. So if we find out dA by dt, then it should be dx by dt, y as it is, plus x as it is, dy by dt. Right? So dA by dt at x is equals to 8 and y is equals to 6 will be, you put the values 6 into, this must be dx by dt is minus 6, so minus 5, and then plus x would be 8 and dy by dt would be 4. The value is minus 30 plus 32, which would be 2 centimeter square per second. So that is how we can solve all of the, the questions will be basic only. So the homework for today, just complete this whole exercise 6.1. There will be one or two questions in which you can face a difficulty. Let me know if you have any doubts tomorrow. Guys, can we have an extra class this weekend also? I may have to take some offs because my placements are approaching, so that is why there will be times when I may not be available because I'll be attending interviews. So this is not happening like right now, but this may happen after 1 or 2 months. So after 1 month, there may be some times where I have to cancel the class. So that is why I'm taking some extra classes. So for that, can we have class on this Saturday at the same time? If anybody is having a problem, you can tell me. We can manage the time and date, day or time. But the classes will be, every extra class will be from 5 to 6:30 Indian time. Just before your regular class, right? So whatever is your extra class for maths, that will always be assigned on just before your regular classes. Okay. Will you be able to attend on Sunday, Madhya? Is Sunday cool for you?
Sir, Sunday at 2:30?
2:30 Indian time, right?
No, sir. Actually, I have classes from Sunday to Saturday. Saturday to Thursday.
Saturday to Thursday. Okay, so
Yes.
this weekend won't be possible for you.
Sorry, what, sir?
This weekend won't be possible for you, right?
Yeah, sir. Actually, I'm only free on Fridays. I
Okay.
have school on Saturdays as well.
Okay. Okay. And so Friday you're free, right?
Yeah, sir.
Okay. Can we have an extra class on Friday? Just a minute. Friday.